Okay, so now we can start talking about ions. So ions formed from one element. These are called monatomic ions. Let's just review what an ion is. Remember from chapter 12, we looked at ions, cations, and anions. An ion is just any charged particle formed when you gain or lose an electron. So cations are positive. Remember, cations are positive because they have this T in there. It looks like a plus sign. So cations are positive, anions are negative. So if you lose an electron, if you lose something negative, you become more positive. So if you lose a negative, if you drop an electron, so you lose an electron, you become more positive, you become a cation. So a lot of these metals all the metals like to give up electrons to become more positive. Remember here we had sodium. Sodium's going to want to give up an electron, become sodium plus, and then he'll look like one of the noble gases over here. Lithium is going to want to give up one electron, so he'll look like a noble gas over here. Everyone wants to look like the noble gases. Anions are these things like the nonmetals, like fluorine wants to gain one electron to look like this noble gas. Chlorine wants to gain an electron to look like this one. And look like, meaning they'll be isoelectronic. They'll have the same number of electrons as the noble gas that it's closest to. So cations give up electrons, anions gain electrons. Monatomic ion is just an ion that has an ion formed from a single atom. So something like sodium plus is a monatomic ion, potassium plus, fluorine minus. Those are all monatomic ions. You can also have polyatomic ions. We'll look at the polyatomic ions on the next page. So the formula of a monatomic ion it's just going to look like this. So it's potassium plus. That's the potassium ion. Potassium ion. F minus. That's called the fluoride ion. Fluoride ion. And if you remember, we need to know these charges. Remember how we looked at these charges earlier on in chapter 12, maybe. Everybody in this first column has a +1 charge, right? They're all +1. These guys are +2. And then we said aluminum was +3. And then working backwards, the noble gases don't gain or lose electrons, so they're not going to form any charges. But these guys will be -1. -2, -3, and it turns out that there are some other elements that have fixed charges. The ones that are white, we don't really have to worry about. Those are either not common or they don't have any charge. Well, here, these guys don't have any charges. These ones will form different kinds of ions, but they'll be able to form more than one type of ion. So if you see here, this is chromium can be +2, +3. Iron can be 2 or 3. Copper could be +1 or +2. So we don't have to memorize those charges. But we have to be able to recognize that they could have more than one charge. And so we'll have to distinguish between the copper 1 ion and the copper 2 ion. And we'll see how we distinguish that in a little bit. But right now, who has a fixed charge? Everybody in this first column likes to be +1. Everyone here likes to be +2. Turns out silver is just +1, zinc is +2, and aluminum is +3. Do you see how this is on a diagonal? And it goes +1, +2, +3. That's helpful for us. So we have everybody over here, +1, +2, and then 1, 2, 3, working backwards. These guys are all -1, -2, -3. And you see how hydrogen's kind of here is a +1 over here, and it's listed as -1 over there. Hydrogen's kind of funny like that, because it only has one electron. It can gain an electron, it can lose an electron, depending on what it's reacting with. So we don't really have to worry about hydrogen right now. We're just going to focus on our metals and our non-metals over here, which are, these guys are -1, -2, -3. All right, so can we write the formula of these monatomic ions? We said potassium, the potassium ion is K+. The fluoride ion is F -1. The name of the monatomic cation, right, we'll just call it the same as the name. So cation is just going to be the same as the element name. The anions, the negative ones, the nonmetals, again, this is the ones from the nonmetals, the ones upstairs, nonmetals, we're going to change that ending to "ide." So instead of calling this the oxygen ion, this is the oxide ion. Whoa. Oxide. Instead of fluorine, this is the fluoride. Instead of chlorine, it's going to be chloride. So the nonmetals, the anions, are the ones whose name changes. We just change the ending of it. So what's the formula of the sodium ion? sodium ion is going to look like sodium plus. So remember, ions have a charge. How is this different than the sodium atom? This guy lost an electron. He has fewer electrons than the sodium atom. So he's an ion because he has a charge. So what are the name and formula? So what are the name and formula of the ion formed by a sulfur atom? So sulfur is going to become sulfide, and let's see what the charge is going to be. Let's find it in this periodic table here. So here is the sulfide ion. It's S2 minus. These are -1, -2. Because it's upstairs, because it's in a non-metal, it's going to be sulfide. So we change the ending of it to sulfide. So this is the sulfide ion. That's the name of it, and the formula looks like S2 minus. So sulfide ion, S2 minus. So a lot of the transition metals are going to have multiple ions with different charges. There's not too many of them that are fixed. The ones that are fixed are here. Silver is +1, zinc is +2, aluminum is +3. That's the only kind of charge that they will form if they're going to be in an ionic compound. But so other ones can change. So the way we distinguish, the copper plus ion from the copper 2+ ions with Roman numerals. We'll use Roman numerals to distinguish one from the other. So we'll say this one is copper, and then parentheses 1 to indicate the charge. That's the copper 1 ion. And this guy is the copper 2 ion because it has a +2 charge. So we have copper, Roman numeral, parentheses, Roman numeral 2 ion. So we use these Roman numerals to distinguish one from the other. 3 transition elements always occur with only 1 charge, so we don't ever use the Roman numerals for them. So nickel is always nickel 2+, nickel 2+. Zinc is always zinc 2+, and silver is always silver plus. And we already said aluminum. Aluminum is not really a transition metal, but it's aluminum 3+. So those are the metals that don't get fixed, that have fixed charges, so they don't get Roman numerals. Group 1 metals are always +1, so they don't get Roman numerals, and group 2 don't get Roman numerals either. So by that I mean, when we're talking about the sodium ion, we just call that sodium ion. We don't have to say sodium parentheses 1 ion, because it's always +1. Magnesium's always +2, so we don't have to say magnesium parentheses 2 ion. Nickel's always +2, zinc's always +2, silver's always +2. We don't really have to worry about the peroxide ion or mercury. Forget about those for just a second. But things like tin 2 or these should say special cases +2 ions. So tin could be tin +2, lead +2, and here you have tin 4 and lead 4. So you want to distinguish those ions from each other. So if it has a +2 charge, then it's tin 2 ion. If it has a +2 charge here for lead, it's lead 2. But it could also exist as +4 and +4. So we have to distinguish between those 2 different ions when we're naming just the ions, and then also when we're naming the compounds. And so compounds in which these ions are present are going to have different properties from other compounds made of ions. So let's see, something like, what's the formula of the copper 2 ion? So we would say copper is Cu, and this 2 means it's +2. So this is the formula for the copper 2 ion. And how would we name this guy? This is cobalt 2 ion. Alright, so you'd have to go back and find, here I have a periodic table. So cobalt, where's cobalt? Cobalt's right there in the middle. It's not a group 1. They're +1 always, no parentheses. It's not a group 2. Those are +2 always, no parentheses. It's a metal. Silver's +1, zinc is +2, aluminum's +3, nickel's also +2. But and you can just, I'm not even going to make you memorize nickel. Just remember 1, 2, 1, 2, 3, and then -1, -2, -3. So cobalt is not one that has a fixed charge. That's why we have to indicate that with parentheses with a 2 on there. cobalt 2 ion. What is the zinc 2 plus ion? That one, we just call it the zinc ion, because zinc is always plus 2. So you don't, do not need 2 there, because it's always 2. It's always plus 2. So you only have to indicate the Roman numerals when it changes. So cobalt is not always plus 2. So these are monatomic ions. We also have polyatomic ions. The polyatomic ions are over here. You have cations. These are positive. There's only one polyatomic cation that we have to know. We have to know this ammonium ion, NH4+. And we're going to treat this, now polyatomic ions are polyatomic. You have many atoms working together with one single charge. So we have to be able to recognize these polyatomic ions. There's one cation. Here we go. These are the ones we have to know. So there's one cation. And then these are the anions. The rest of these are anions. So this is the ammonium ion. OH minus is hydroxide. We need to know the name, the formula, and the charge. So that's hydroxide. Nitrate is NO3. And chlorate is ClO3 with a minus charge. So I usually group them together by charge. Those all have -1. These are -2, and that one's a -3. So hydroxide, nitrate, chlorate, sulfate, carbonate, phosphate. These guys all end in -8. I'm going to show you how to get the ones that end in -ite really easily later on. But we have to start by memorizing all of these guys. So the ammonium ion, hydroxide, nitrate, chlorate, sulfate, carbonate, phosphate.